Hello, and thank you for watching. In this analysis, I want to do a step-by-step process of how to use sentiment analysis. So this is another project I had completed in the past and want to share with you guys. So we will be building and exploring the uses of neural networks and neural language processing. This technique can be useful for companies to receive fast, important information for better business decisions. So building a neural network within TensorFlow is the main objective of this analysis, and to use techniques to evaluate and predict sentimental analysis for prediction. So sentimental analysis is a fast technique to analyze customer reviews. Rather than having a human process the data, it can help detect and deliver better insights. So we will analyze past data on customer reviews by using data sets from Amazon, Yelp, and IMDB. I'm going to go ahead and start the process. So of course we have to always import our libraries into Python. And these downloaded needed. I had to download these myself. So you can just go ahead and remove these little number signs or pound and run this installation. But since I already did this, I'm going to go ahead and just put it as a text so it doesn't run it. So those are the downloaded needed. If you want to check your versions of what you are running, this is another way to check each version. This is your TensorFlow version and what you're running. Next, I'm going to import my data. So again, we're going to be analyzing the past data on customer reviews by using data sets from Amazon, Yelp, and IMDB. So of course, this is the code you're going to need. And this is the file location. I have the Amazon text file, IBM text file, and the Yelp text file. I'm going to go ahead and run that. Then I'm going to review each file by checking their shape. You can see IMDB has 1,000 columns, 748 for Yelp, and Amazon is 10,000. So just to keep in mind, this data does not have headers or variable names on the rows. It's just all data. So there's 3 data sets, and we will be joining them into one data set. So this is what this code is for now. So I am making a df_list and putting all 3 of those data sets into one list. And then I did a df equals pd.contact by list. So then I'm going to be naming the columns. So as I said before, there is no names, but now that I went ahead and named these columns, I'm going to name it reviews for the text review and sentiment for the numerical data. So as you can see here, by just reviewing this, customers are reviewing 1 for good and 0 for bad. So next I'm going to go ahead and do the shape of the data now that it's all combined into one. So now that it's all combined into one, we have 2,748 rows and 2 columns. And then I'm going to check the sentiment column, which is this one up here. And customers that rated 1, we have 1,386 customers, and customers that rated 0 is 1,362 customers. There's also the data type, which is an integer for those columns, for that column. So now I'm going to do the processing, cleaning the data. So I'm going to check for null values, which is both of these rows, the reviews variable and the sentiment variable, both have 0 null values. And this next section, I'm going to change all uppercase letters to lowercase letters in the column reviews. So all that text that the customers had wrote out and typed out, we want them all to be lowercase. So that's what this code is for. Then I'm going to go ahead and remove punctuations from the text, just periods, question marks, exclamation marks, etc. That's what this code here is for. And then I'm going to do a DF drop reviews any NA values. So if there's any NA values, which we saw up on the top here, null values, so there's none, but just in case. Then I'm going to do a special character, so I'm going to remove all special characters, such as like customers that might be putting like happy faces, sad faces, or stuff like that. Those special characters are going to be dropped. And then we're going to be removing numbers from the text. So any numbers that are in the text will be removed. So I'm going to go ahead and run this and view it. And as you can see, there are all lowercase letters, and there's no special characters, periods, punctuations. It's just all lowercase letters. So next we're going to do our vocabulary size and embedding size. So I'm going to run that. And this shows the vocabulary size, which is 6,163, and our embedding size is 8.86. Next we're going to do our stop words. And our stop words, they're going to be dropping anything that is not shown for this analysis. So basically what Python does is it grabs all the important words, like such as good, bad, not good, so on and so forth. So there are 16 stored lists in different languages in Python that helps remove these stop words from our data. And printing out these stop words, these are the stop words that are going to be removed within the text. So then next we're going to go ahead and split the data. And again, it's going to be 80% testing, 20% training, and that's what this process is here. Then we save a copy of the prepared data set. So you can go ahead and copy it and save it to whatever file you want it to save to. In this case, I saved it to my C file, and it will be saved there. And that's what this code is for. Now, tokenizer. So your tokenizer and padding sequence, this is what we are going to do next. As you can see, the number of words, I put 6,163, which is what was up here, 1,163. So that's what that vocabulary size helped me to insert that those number of words there. So that's what I put here. So I'm going to, and then this is the libraries I use for the TensorFlow. So I'm going to run this. And as you can see, that all of these words are now assigned to a number. So that's what the goal of using tokenizer process is, to break down textual data into numerical data. Putting the text into numerical data will allow the computer to discover and find useful actions and responses. So that's what that's doing there. So the padding sequence is next. So the padding sequence is performed to standardize the length of the sequence. Not all the sentences in the dataset are the same number of words, and this process will help us with maximum number of words for each sentence, and that's what it's doing here, as we printed it, and it printed out the padding sequence. So now we're going to start the model building. So of course there's your libraries for the TensorFlow, creating the model. So the 10 is the embedding size within line 7. So in line 7, that's the embedding size. I'm going to set it to 10. And then we're going to compile the model. So I'm going to run that. And here it is. So this is the model. So here's your embedding, the output shape, and parameters. The total parameters is 73,881. And then the next is going to be the early stopping. So this is going to take a little process. And this is the model.fit, X train, Y train. Epochs, we're going to set to 20. So it's going to stop at 20. So we're going to let it go ahead and run there. It takes a little bit. So going back to in the embedding part up here while that runs, the first layer, it has, as you can see, has 3 dimensions. And the way I can see that is it has 1, 2, and 3. None means that there are no specific numbers of the batch size to use. And the bottom of the model right here indicates that the total number of parameters of the model, which is the LSTM, which stands for long short-term memory, is 73,881. Now going down to the early stopping, still processing. As you can see that star there, once it hits a number, it means it's stopped. But again, it's going to do epochs 20. So this here helps us with the overfitting and underfitting. So the most common issue that occurs when creating the training model used in the neural network is overfitting and underfitting. So assigning an appropriate number to epochs, which is this here, is important because that is when the problem usually occurs. To prevent this issue of overfitting or underfitting, the early stopping criteria of the pandas library will help by tackling the problem and stopping the model when it encounters a reduction in the validation loss. So this will stop validation training model at epoch 20. So once it stops, we get the model accuracy, which is 62%. Then we do the model accuracy and loss next, which does it creates an output of the graph. And here you can see that there's the training and testing. And red is for training, and blue is for validation loss. Oops. And then there's another one. So the first model, the first visualization is training and validation accuracy, and the second one is training and validation loss. And the next is reviewing the matrix results. 62%. And then next we'll go ahead and save our model as a .json file. So that's what this code does, is it saves your model. And then here is my resources. So that's the end of my tutorial. I hope you enjoyed it. If you liked it, hit the like button and don't forget to subscribe.